Straight. So in the different configuration is we are get the different terms. We are using the different terms. How to get that the terms? That is LS coupling. What about that LS coupling? So based on the LS coupling, the different types of terms are generated. Different types of terms are generated. So based on the different types of configurations. For example, you can D1 D9 configuration one pair, that is a whole formalism. D2 D8 is another pair. D3 D7 is another pair. D4 D6 is the another pair, and D5 is the separate configuration. That means half field configuration. These are all different types of configurations. You can use the different types of terms. Different types of terms. Based on these all type of terms, generally we can frequently using the terms are D and F terms. D and F terms. Okay. Based on the Argel is the scientist who has proposed or explained the three diagrams, who has suggested the three diagrams. They are called what? Argel diagram. They are called what? Argel diagram. So based on the Argel diagram, you can explain what is the terms are used in which configuration, and the terms are used in the different configurations are there based on the different configurations. Okay, different types of splitting is takes place. So before going that, small explanation is there. We can explain that. After that, we can explain the original diagram. What is the explanation? Okay, so in general, the terms are, we can apply the magnitude of term. The terms can divide into different energy levels. That is the angular momentum. We can say that was angular momentum. Similarly, orbitals also we can apply the magnitude. They are undergoes the orbital angular momentum. They are give the orbital angular momentum. That means in that orbits are contain how many subcells. How can you explain? One equation is there. What is equation? 2L plus 1. This is can use for orbital explanation. 2L plus 1. This is can explain for the term. This is explain the term. For example, S orbital is divided into how many subcells? How can you calculate that? What about the S L value? L is equal to 0 for S orbital. L is equal to 0 for S orbital. In this 0 value, you can substitute in this equation. 2L means 0 plus 1. 2 into 0 is equal to 0 plus 1 means 1. S orbital is contain only one subcell. That is what? Only S orbit. In this bit is contained the two electrons only. Okay. Similarly, S term also. S term also can divide. Here, S term we can use the L value is 0 for S term. L is equal. This is a capital letter. L value 0 for S term. Okay. Based on this value, you can substitute here 2. In the L place, you can substitute the 0 plus 1. That is equal to 1. One energy pocket is there, or one energy level is there. Similarly, p orbital, similarly d orbital, similarly f orbital. Okay, s orbital means p orbital and p term also similar. P orbital is contained. What is the explanation here? Okay, in the p orbital is contain how many subcells? P orbital is contain how many subcells? How can you explain that? Based on that equation, 2L plus 1. What about L? L is equal to 1. That means 2 into 1 plus 1, that is equal to 3. In the p orbital is contain three subcells. They are what? Px, Py, Pz. Px, Py, Pz. Or plus 1, 0, minus 1. Based on the angular momentum, we can write these values. Based on the name, we can write these names. Similarly, that p term also, p term, L is equal to 1, p term. What is the equation? 2L plus 1. What is the equation? 2L plus 1. In the L place, we can substitute the 2, 1 plus 1 is equal to 3. The p term also contain three energy pockets. Okay. What is the difference? Both are same. P orbital and p term both are similar properties. That means what? Similar means is a contain three energy pocket, three suborbitals. This contain three energy pockets or three energy levels. But there is no discrimination. But there is no energy barriers are not there in the p orbital. All p orbitals are similar energetical. All p terms are similar energetical. Okay. Similarly, what about the S? What about the d orbital and d term? Similarly, what about the d orbital and d term? Okay. This is useful for in this diagram. So these terms are useful for in this diagram. That's why we can explain that. What about the d orbital? Okay, d orbital means 2L plus 1. That means d orbital d is equal to 2. Means L is equal to 2 for d orbital. Here we can substitute L plus in 2 plus 1 is equal to 2 into 2, 4 plus 1, 5 suborbitals are there. P orbital, d orbital is contain 5 suborbitals. They are what? Can give the name of that dxy, dxz, dyz, dx square minus y square and dz square. In this orbital, is contained the central atom or metal atom. That metal is not approaching the ligand. All are similar. When the metal is approach the ligand, this orbital is splitting takes place based on the different geometries. Based on the different geometry. So here we can explain about octahedral geometry. Octahedral geometry. How to split the d orbital? How to split the d orbital? Means d orbital is contain 5 suborbitals. They are split into two energy levels. One is a triply degenerate orbital. The name is the T2Z. One is a doubly degenerate. The name is the EG. Okay. This is for octahedral. What about tetrahedral? Tetrahedral also divide into two subcells, so two energy levels. That is the reverse for the octahedral. So here go to the T2, here E. So what about the G here? G is nothing but symmetrical splitting is takes place. G is the Girade. That is the Greek word. Girade is nothing but symmetrical pattern. The splitting is takes place in symmetrical pattern. Okay. U, here you can mention the T2U or EU. What about the U? U is nothing about the ungirate. U is nothing about the ungirate. That means the d orbitals are splitting in unsymmetrical pattern. What about the tetrahedral geometry? What about the tetrahedral geometry? That means the splitting of d orbital in octahedral and tetrahedral. What happened? Reverse opposite pattern is there. Here in the octahedral geometry, T2G is less energetic or low energetic or less shielded orbital. Okay, EG is the more shielded orbital. EG is the more shielded orbital. Like that, in the here in the tetrahedral geometry, E is the or EU is the less shielded. T2 is the more shielded orbital. So like that, this is nothing about the p orbital. This type of explanation we can explain in the offline class and the first class we can explain that. Now what about the L term? So what about the D term? D term are contain how many energy levels? How many energy levels and how to split that? How to split that? What is the equation here? Capital L is equal to, you can use in the term or capital L is equal to, we can use the term or D term. What is the equation? 2L plus 1, that is equal to into 2 plus 1 is equal to 5 energy levels, energy pockets are there, are 5 energy levels are there. We can apply the magnitude of in this energy levels. They are also split into two different energy levels, energy levels. How to split that? Okay, for example, in D2 configuration, D2 configuration, how to split that D2 configuration? So here T2G, this is the EG. Similarly, how to split the d orbital? D term also like that, splitting is takes place. Okay, so here three energy levels are one type, two energy levels are one type. This is for about a D2 configuration. D2 configuration is the less than half filled configuration. Less than half filled configuration. What about the similar configuration for the more than half filled? What is the pairing of D2? What is the pairing of D2? That means similar properties are obtained. The one configuration is there that is more than half filled. That is what D8 configuration. D8 configuration also contain the D term. We can use the D term. This is also we can use the D term. In that D term, how to splitting is takes place or D2 or D1 any configuration. We can use the D term or D1 configuration. This is the D9 configuration. Here D3 is at here D7 configuration. Less than half filled, more than half filled. In this all D configuration are using that term is a D term is repeated term is there. So what about the more than half filled? So this is a reverse splitting is there. For example, here D1 is there. This is the D9. What about the D1? T2G term is the less energetic. EG term is the more energetic. What about the energy gap here? The energy gap similar octahedral splitting. This is a T2G means minus 0.4 or 4 dq. Here, what about this? Plus 6 dq. 6 dq is a 4 dq, not 0 I mentioned here. 4 dq here, 6 dq. What about the D8 configuration? What about the D8 configuration? D8 configuration is a more than half filled. More than half filled. How to split the d orbital? Here, the T2G term is go to the higher energy level. T2G term is go for higher energy level. T2G is go for higher energy level. EG is the low energy level because of reverse of the uh, less than half fill configuration, less than more than both are opposite variation is there. The energy level is changed into opposite position or opposite orientation. So this is one change is there for the d orbital and the d term. D orbital splitting any configuration. D orbital splitting any configuration D1 to D9 any configuration similar splitting is there. T2G EG similar, but here less than half filled. One type of splitting is there. More than half filled. One type of splitting is there. So here this is the means change the energy level. EG is low, here high. T2G is high. Here EG is high, T2G is low. Like that. Okay. So based on this, we can explain the terms or RGL diagram or RGL diagram. Okay. So what about the F term and F orbital? What about the F term and the F orbital? So F orbital is nothing but L is equal to 3. L is equal to 3. That means 2L plus 1. That is equal to 2 into 3 plus 1. That is equal to 7 suborbitals are there. F orbital is contains 7 suborbitals. They are how to split that F orbitals? 3 energy levels. Split is the 3 energy levels. F orbital. Okay. They are what? T small t2g, small t1g, small t2g, and a2g. Okay, a2g. Okay. T1g means triply degenerate. T1g means T2g means triply degenerate. A2 means singly degenerate. Means these are the three suborbitals, one level. Another three are another level. One is the another level. 3 plus 1. That is a 7 suborbitals are there. That means what that in the F orbital is contains 7 suborbitals. they can split into three different energy levels. What is the name of f orbitals? The name of f orbital is the, we can write the name of f orbital, we can sorry, we can understood that. What is the shape of f orbital? F orbital shape. Now, the names. What is the name of that? D dx into y square minus z square. Dy into z square minus x square. Dz into x square minus y square. These three are one type. Next, dx cube, comma dy cube, comma dz cube. These three are one type. And dxyz. These three are one type. Okay, that means what? That means what? This is the one set of orbita. One, this is the A1, A2G. The name of this A2G. These three are another type. That is the T2G. The name is the T2G. These three are another type. The name is the T1G. Okay. T1G are three suborbitals. T2G also three suborbitals. A1G is the one suborbital. 3 plus 1 is nothing about 7 suborbitals are there. They can divide into three energy levels. They can divide into three energy levels. Similarly, F term also. Similarly, F term also can divide into how many energy levels are there, how many energy pockets are there. F term is contain how many energy levels, how many energy pockets are there. You can explain that. Okay. So F term means F is equal what? Sorry, L is equal 3 for F term means 2L plus 1. That means 2 into 3 plus 1 is equal to 7 energy levels are there. 7 energy levels are there. In that 7 energy levels are split into 3 energy, 7 energy pockets are there. They are split into 3 energy levels. Similarly, the how to split that f orbital? That means this is the T1G, this is the T2G, this is the A2G. Okay, this is for example D2 configuration. What about a D8 configuration? What about a D8 configuration? In the D8 configuration also, D8 configuration, for example, how to split that? Like that. This is the A2G, this is the T2G, this is the T1G. This is the D8 configuration. D2 D8 configuration are exhibit the similar property, only except this. So here the energy levels are split less than half filled in this pattern, more than half filled in this pattern, reverse of the less than half filled pattern. Okay. Based on this type of splitting is there in the D term, F term. So based on this, Argel is suggested. He was explained different configurations and which type of terms are get in the different types of configuration. So based on the all configurations, was conclude one point. Was conclude one point. What is that? Argel is suggested three diagrams. They are, first one is the Argel diagram for a D term. What is the second diagram? Argel diagram for F term. What is the third diagram? Argel diagram for a separate D5 configuration. Argel diagram for separate D5 configuration. What about the D term? D term is nothing about that is repeated in some various configurations. Which type of configurations are repeated the D term? Which type of configurations are repeated the F term? Which type of config is repeated the D5? The D5 configuration is the 252 microstates are there. So that way, that is a different diagram we can explain. Okay, you can observe here. You can observe. Okay, so Argel diagram is plot a energies of terms derived from various configurations. Okay, versus crystal field splitting. The Argel is draw the diagram from the various configuration versus crystal field splitting, that is the DQ. Okay, so as field strength is increased, the degeneracy of orbital. Hello, any doubt? So go to mute, all of you. Mute కెళ్ళండి. So RGEL, as field strength is increased, the degeneracy of orbital splitting also increase. So RGEL has suggested only 3 diagrams for all the terms derived from DN configuration.
Sir,
Tell.
sir, dn is equal to d5 plus n. Give similar type of diagram. dn is equal to
DN is
d5 plus n.
DN
As we
means
are
the
writing,
various configurations. No, DN. N is nothing but what?
yes, sir, that I want one more
N is
time.
the electrons are present in the d orbital. N is nothing but number of electrons are present d orbital. Based on that, we can explain the terms. Based on the term, RGEL is suggested 3 diagrams. I can explain the diagrams. Okay.
Yes, sir. Thank you, sir.
N is nothing but number of electrons. Based on the electrons, the terms are used. We can explain the which electron configuration, which terms are used. We can explain now. Okay. So what is the conclude point? RGEL has suggested only 3 diagrams for all the terms. For all the terms derived from the DN configuration. Derived from the DN configuration. So what is the diagrams? One diagram for all D terms. Another diagram for F term and the separate diagram for D5 configuration. You can observe here. You can observe here on means RGEL one diagram for D term, one diagram for F term, and separate diagram for D5 configuration. Okay, 3 diagrams are we can explain. Okay, now we are explain about the RGEL diagram for a DN term. N is nothing but number of uh, electrons, the DN configuration. N configuration, that is. Okay, so which type of configurations are using the D term? Okay, D term can using the D1 configuration, D9 configuration, D4 configuration, and D6 configuration. What is the configuration? The 4 configurations are used for the D term. Okay, you can observe here. Okay, the D term or DN term can use it for the what is the configuration? D1 configuration, D4, D6, and D9 configuration. Based on this configuration, RGEL is plot one diagram. RGEL is plot one diagram. The diagram is nothing about RGEL diagram for T term. How can you draw the diagram? Okay, observe here. Just wait, I will explain that. This is the 0, this is the DQ, this is also DQ. This is the right hand side diagram, this is the left hand side diagram. Okay, right hand side diagram, this one is the left hand side diagram. Okay, this is the energy barrier 0. Okay, this is the energy barrier 0. So how to split the energy levels of D term? The D term can split into 2 energy levels. One is the T2G, here is the EG, T2G and EG. Okay, so in the right hand side, one configuration is octahedral. In the opposite side is change their configuration. change the configuration and change the geometry also. So for example here D1 and a D6 configuration. You can observe here D1 and a D6 configuration for right hand side. D1 and a D6 configuration for right hand side. Okay, you observe in this diagram you can observe. Okay, this observe here D1 and D6 configuration for octahedral split like this. The diagonal splitting takes place like this. What about the opposite for tetrahedral? Okay, opposite for tetrahedral. D1, D6 opposite for tetrahedral. Opposite diagram can explain the tetrahedral manner. So here in the right hand side, D4, D9 is the tetrahedral. D4, D9 is the tetrahedral. In the opposite manner, D4, D9 is the octahedral geometry. Means what? In this diagram, okay, right hand side is one type of explanation, left hand side is the one type of explanation. For example, here octahedral splitting is there here, tetrahedral. Here octahedral is there here, tetrahedral. Okay, the energy levels are this octahedral in right hand side. Similarly, opposite in tetrahedral opposite side. Octahedral right hand side, which type of splitting is takes place? Opposite side in the left hand side, similar splitting but opposite similar splitting. For example, here T2G here low, here T2G is the high. That is the tetrahedral, here octahedral. Okay, both configurations, different configurations are there. So you can observe the diagram clearly understood about that. Okay. So what about the octahedral tetra? What is the difference in the octahedral geometry? We can use the word is G, zero. In tetrahedral geometry, you can remove the G. You can remove the G. Remaining all similar. Remaining all are similar. Like that, origin diagram for F term also is there. Okay. You can means you observe here d term once again you can observe here simple thing here, there no confusions are there. Okay, what about that? So in the right hand side, T2G is the low energy, EG is the high energy. In the right hand side, T2G is the low, EG is the high energy. Okay, opposite this EG comes here. Okay, that T2G comes here. Means here octahedral explanation is there here, tetrahedral explanation. So you can observe here D1 D6 octahedral, D1 D6 tetrahedral in opposite diagram is the tetrahedral explanation is there, same configuration, opposite is the different splitting. In here D4 D9 tetrahedral in right hand side, D4 D9. Here D4 D9 octahedral in left hand side. This is octahedral, this is the tetrahedral. Okay, like that. These four configurations D1, D2, D3, sorry, D1, D4, D6, D9 configuration are frequently used. The term is D term. Based on the D term, RGL suggests one diagram, RGL diagram for a D term. This is the explanation about that. So here we can write the octahedral, mention the G. Tetrahedral, you can remove the G and insert the U. G is gyrate, U is ungyrate, U is ungyrate. This is nothing about the RGL diagram for F term, RGL diagram for D term. What about the F term? F term also similar. F term also similar. But here RGL diagram for F term. Which configurations are used for F term? Which configurations are used frequently in F term? So F term we can use the different configurations are there. What is the configuration? D2 configuration. D2 configuration is contain 45 microstates. In that 45 microstates, 21 times repeated the F term. 21 times. That means D2 configuration, the mostly using the term is F term. Okay. So D2 configuration, D3 configuration, D7 configuration, and a D8 configuration. These four configurations, the frequently using the term is F term. The frequently using the term is F term. Okay. So based on that, we can explain their uh, diagram. We can explain the diagram. Similarly, here also same. F term can divide into three energy levels. F term can divide into three energy levels. What is the energy levels and how can we explain that? So observe here. Wait, just wait. I will put the this is nothing about the original diagram for F term. Okay, original diagram for F term. So the F term can split. F term is contain how many energy pockets? Seven energy pockets. How to split that? How to split that? For example, like that. F term can divide into three energy levels. One is the T1G, triply degenerate. Another one the T2G, that is also triply degenerate. Another one is the A2G, that is a singly degenerate. Okay, this is the T1G. Okay, this is the T2G. This is the A2G. Okay, so what is the explanation here? Same explanation. Same how to split the D term here also same. So, for example, you can observe the diagram. So, right side diagram. This is the right side diagram. In the right side diagram, D2, D7 octahedral geometry split like this. In this type of splitting pattern, in which configuration? D2 and D7 configuration. D2 and D7 configuration split like this. T1G, T2G, A2G. This is for D2 and D7 configuration. What about the opposite side for this configuration? What is the opposite side? The opposite side is the tetrahedral. Same pattern, tetrahedral. You can observe the same pattern. That is the tetrahedral. You should observe here. Okay. D D to D7 tetrahedral opposite. Reverse the diagram. So reverse means what here? This is the A2G. This is the T2G. This is the T1G. A2G, T2G, T1G. Like reverse like this. This is the A2G. This is the T2G. This is the T1G. Okay. So reverse. This is which configuration? D2, D7 for left hand side diagram. Left hand side diagram. So here octahedral in right hand side, tetrahedral in left hand side. Same configuration. Octahedral right hand side. Which type of energy levels are there? Opposite side, tetrahedral, same energy reverse. The low energetic is go to the high energy, high is go to the low energy. That is that is the splitting of F term. The F term there is these two configuration. What about remaining other two configuration? D2, D7 this. What about the D3, D8? What about the D3, D8? Okay. In the D3, D8 configuration, you can observe here. Okay. D3, D8 configuration. In the right hand side diagram is tetrahedral. Right hand side diagram is splitting like this for D3 and D8 configuration. D3 and D8 configuration for tetrahedral geometry. What is the opposite side? Same. D3, D8 is the octahedral. You observe here. D3, D8 is the octahedral in the opposite side. Opposite side. Like that. For the tetrahedral complex, the subscript G is eliminated. The subscription G is eliminated. G is not using for the tetrahedral geometry. Same splitting is there. and one degeneracy is there, non-degeneracy is there. That means here in the observe this diagram. Here p term also involved here. The left hand side, p term T1G is more energetic. P means p term is contain three energy levels. That is a T1G for P. T1G for P. That is in the right hand side is intercrossing the A to G term. Intercrossing the A to G term. That is a that is called what? Non-degeneracy. That is called what? Non-degeneracy. So here observe here in this diagram. So this is about the A to G term. Okay. So the intercrossing the what is the term? T1G term for P T1G energy level for the P term. Intercross. This is the A to G, this is the T1G. What about in the left hand side? That is T1G is the T1G for P term is the more energetic. That is called what? Non-degeneracy rule. That is called what? non Why that is the intercrossing for that? So in the P term and F term are contain various spin multiplicity. Contain the various spin multiplicity. That's why that's why the in the right hand side pattern one type is there, in the left hand side pattern one type is there. Means only that only for that. Okay. So this is nothing about the F term. This is nothing about the F term. What about the D5 configuration? The separate diagram for D5 configuration. In the D5 configuration, we can using the terms are in that we can using the terms are different terms are used. Why? Because of in the D5 configuration are contain 252 microstates. 252 microstates. That is we can using the terms are these terms. We can using the terms for D5 configuration. This term we can use 4G, 4P, 4D and 4F. These all terms are used. Based on the terms, we can explain their energy levels. We can explain their energy levels. We can put the another page. Just wait. Just wait. So different terms are used. 6S term for means based on the energy level. 4F, 4D, 4P, 4G. Okay. So 4F term can divide into F term can divide into three energy pockets. Okay, like this. F term. Okay. T1G, T2G, A2G. D term. T2G, EG. P term. Only one is there. What about the G term? G term means L is equal to 4. L is equal to 4. How many energy levels are there? How many energy pockets are there? 2L plus 1. Here L is nothing but what? 4. Means 2 into 4 plus 1 is equal to 9 energy pockets are there. G term or contain 9 energy pockets. In that 9 energy pockets can split into 4 energy levels. One is the triply degenerate, other another triply degenerate. One is a doubly degenerate, one is a singly degenerate. Triple degenerate 3 plus another triple 3 plus doubly 2 plus singly 1. Total how many? 9 energy levels are there. 9 energy pockets are there. In that 9 energy pockets can divide into 4 energy levels. 4 energy levels. What about S term? Only one energy pocket is there. Okay. Like that, like that in the D5 configuration, we can plot a one diagram. We can plot the one diagram. We can observe the diagram. Okay. So we can share the another like this. Okay. So this is the organelle diagram for D5 configuration. Organelle diagram for the D5 configuration. Okay. 6s. S is nothing but there is no energy pockets are there. There is no energy pockets are there. So that's why that is contain only one energy pocket. What about the 4G term? 4G term are contain 9 energy pockets. They are split into 4 energy levels. T1G, that is a 3 triply degenerate. T2G, triply degenerate. EG, doubly degenerate. A2G, singly degenerate. Singly degenerate. That means 3 plus 3 plus 2 plus 1. That means 9 energy levels are there. What about P? Here also, based on the spin multiplicity and LS coupling value, then orbital angular momentum value and their magnitude, based on the all properties. Here, P term is go to the high energy level. Compare the D term. Compare the D term. That is only one energy pocket is there. That is the T1G for P term. T1G for P term. What about the D term? D term can divide into two energy pockets or two energy levels. One is the T2G, the triply degenerate. One is the EG, that is the double degenerate. 3 plus 2, 5 energy pockets are there. P is the 3 is there. What about F term? What about F term? That is can divide into means 7 energy pockets are contained. They are T1G, T2G, A2G. T1G for 3, T2G for 3, A2G for 1. 3 plus 3 plus 1. Total 7 energy levels. Energy pockets can divide into 3 energy levels. This is nothing about the orbital means splitting of F term, splitting of the terms in various terms in D5 configuration. Frequently using the 252 microstates, can frequently using the terms are D term. We can frequently using the terms are these all terms. You can use the S term, you can use the G term, use the P term, use the D term, and use the F term. Repeated usage of this term. Based on their energy level, this type of splitting is takes place. So in these three diagrams, one is compulsory given for the examination. Okay, and in this chapter, some important questions also is there. Okay, what is the terms and states and microstates? Calculate the terms, states and microstates, and calculate the microstates of various configuration, DN and PN configuration, various configuration. Okay, define spin and orbital angular momentum. Define spin angular momentum and orbital angular momentum. Important question that. Define the orbital magnetic and spin magnetic moment. Okay, define the orbital magnetic moment and spin magnetic moment. We can apply the magnitude of that. Okay, different coupling values are obtained. Whatever the next question, LS coupling. Okay, in the orbital coupling is there, spin coupling is there, spin orbit coupling is there in that question. And what about the spin orbit coupling for D2 and D2 system, P2 and D2 system? Okay, spin multiplicity, whole formalism, JJ coupling, LS coupling. So different types of questions also you can ask for the examination. Some important questions are there. So this is nothing about the what is the chapter that is in black. I think three. I think three. Bonding in metal complex two. The different types of diagrams are there. So uh, now we can start the another new topic is there. What is the topic that ligational aspects of last block? Ligational aspects of diatomic molecule. Okay, some molecules are acting as a ligand, and that is the formation of which type of complex, and the formation of different complex are formed. That complex are means one connect one another, and the formation of one clusteral form that is called what metal cluster. That is called what metal cluster. Okay. Uh, so you can share that chapter. Ligational aspects of diatomic molecule. Ligational aspects of diatomic molecule. That means what? Some molecules. What is the mean by ligand? What is the mean by ligand? Ligand is nothing about ligand. Last block. This is ligand is nothing about electron pair donor. Electron pair donor. Okay, that is called what? Nucleophile antam. That is called what? Nucleophile. Electron rich species. Electron rich species. So this type of ligand, electron donor is acting as some molecules. What is the molecule? Diatomic neutral molecules. Diatomic neutral molecules. They are what? CO, carbon monoxide is acting as a ligand. Okay. Dinitrogen also acting as a ligand. Okay. NO, nitrosyl, is acting as a ligand. O2, diatomic molecule, is acting as a ligand. Water molecule also acting as a ligand. These all are what? Neutral molecules. These all are neutral molecules. In these all neutral molecules is acting as a ligand. Means these all neutral molecules are contain the electron pairs to donate the electrophile. Electron pair donate the electrophile. Okay. The electrophile are attract the electron pair from this ligand, this diatomic molecules. That's why what is the point? This diatomic molecules are acting as a ligand. In this all diatomic molecules, CO is the most important molecule. CO is the more important molecule. Carbonyl. The name is what? Carbonyl. The carbonyl is bind with the metal. The formation of metal carbonyls. The formation of the metal carbonyls. Okay. That is there here. Okay. Ligational aspects of diatomic molecule. Okay. The CO is the stable neutral molecule. CO is a stable and a neutral molecule. Okay. So in that neutral molecule is bind with the ligand and the formation of metal carbonyls. Metal metal is by n number of metal is bind with the y number of CO. The formation of the complex is NCOY. Here n is equal to number of metals, y is equal to number of carbonyls. So based on this M, based on the N is equal to 1, mononuclear carbonyls, N is equal to 2, binuclear, N is equal to 3, trinuclear carbonyls, N is equal to 4, tetra, like that. So based on this all type of classifications, the metal carbonyls are classified into two types. One is the LNC, HNC, low nuclear carbonyls, low nuclear carbonyls and high nuclear carbonyls, low nuclear and high nuclear carbonyls. Okay. So today we can stop the class. Tomorrow we can explain the remaining this part. Okay. Now some small work is there. Stop the class today. Okay. So you can join the next class. 7:30 class is there. You can join the class. To continue that tomorrow in this chapter. Tomorrow we will continue the class.
Okay, sir.
Okay. Any doubt is there?
Sir, hello.
Tell.
Sir, this is carbonyl formula Nm plus YCO. N is equal
Uh,
to number of metals.
uh,
And Y, sir?
Y is the number of carbonyls, CO.
Yes, sir.
So based on the N and based on the Y, you can classify the metal carbonyls. We can
Right.
discuss about tomorrow for that. Okay.
Okay, sir. Thank
Join the tomorrow class 9 to 11, 10:30. Okay.
you, sir. Good day, sir. Thank you, sir.
Leave
హలో
the class.
మీకు క్లాస్ టైమింగ్స్ మారినాయి అని చెప్పారు సార్ కోటేశ్వరరావు సార్.
రేపా ఇవాళ?
రేపు సార్, రేపు 10:30
రేపు
అని
మార్నింగ్
అన్నారు.
ఉంటాయి. మార్నింగ్
మార్నింగ్
9:30కి ఉంటుంది రేపు.
అదే 10:30 అన్నారు సార్ మార్నింగ్ క్లాస్ లోను.
సరే 10:30 అప్పుడు జాయిన్ అయిదాం. 10:30కి జాయిన్ అయిదాం.
అదే షెడ్యూల్ పెడతా అన్నారు సార్, పెట్టలేదు.
ఓకే
10:30
ఓకే.
స్టార్ట్ అవుతాయి అని చెప్పి అన్నారు.
యాజ్ పర్ షెడ్యూల్ ప్రకారం జాయిన్ అవుదాం.
ఓకే
సో
సార్, ఓకే సార్.
అర్థం అవుతుంది కదా క్లాసు?
అర్థమవుతుంది సార్.
కొంచెం బుక్ ముందర పెట్టుకోండి. మెటీరియల్ కూడా షేర్ చేశాను ఆల్రెడీ. కొంచెం చూసి అప్పుడప్పుడే
సార్
చదువుకోండి.
షేర్ చేస్తారా సార్ ఈ నోట్స్ ఏమన్నా? ఈ మెటీరియల్ ఏమన్నా షేర్ చేస్తారా సార్?
ఆఫ్టర్ కంప్లీట్ ద ఆన్లైన్ సెషన్ ఐ విల్ సెండ్ ఆల్ మెటీరియల్స్. నేను ఒక అమ్మాయిది నెంబర్ ఉంది నా దగ్గర. అమ్మాయికి సెండ్ చేసి మీరంతా తీసుకోండి. ఓకేనా?
ఓకే సార్, మేము రన్నింగ్ నోట్స్ రాసుకుంటున్నాము. ఇద్దరిని కంపేర్ చేసుకుని
I will send the material, complete material I will send.
ఓకే సార్, ఓకే సార్.
Okay.
థ్యాంక్ యూ సార్.